Dear students, last class we have discussed about concept learning as task. How the concept learning happened with the specific example. We have seen the enjoy sports water game. With that, the concept learning task can be explained in the previous class. So now we are going to see the concept learning as search. So why that search is required means that hypothesis space will be more. Okay, there's a large space. From that, we have to identify the best fit area. Okay, so for that, we need a search. We have to search the entire hypothesis space and we have to identify the best fit strategy. Okay, so we'll see one by one. We'll see this this class. So concept learning as search. That means concept learning can be viewed as the task of searching through a large space of hypothesis. Okay, implicitly defined by hypothesis representation. Okay, so that is find the hypothesis that best fits the training example. That is the goal of this approach. Then, for example, that we have seen the water sport game, no? The instance is X. There are instances X and hypothesis sketch in water sport game, a learning task. The attribute sky has 3 possible values. Already we have seen there are 6 attributes. Among the 6 attributes, attribute sky takes 3 possible values: air temperature, humidity and wind. Other 5 attributes, it took only 2 possible values. So the water forecast each have 2 possible values. That is other attributes like air temperature, humidity, wind, water forecast all takes 2 possible values. So the instance space X contains exactly 3 because that sky attribute took 3 possible values. Remaining 1, 2, 3, 4, 5 other 5 attributes took 2 values. So 3 into 2 into 2 into 2 into 2, that is equal to 96 distinct instances will be there. Because each attribute is taking for first attribute 3 possible values. So based on that thing we are finding the permutations and combinations. And then 5 into 4 into 4 into 4 into 4 equal to 5120 syntactically distinct hypothesis within H. How this 5 came means along with these 3 possible values, it will take the any value, that is question mark, as well as it will take the null value pi. So 3 plus 2 5. Then same thing for another attribute air temperature, that it will take the 2 possible values along with that pi and null. So 2 plus 2 4, 2 plus 2 4, 2 plus 2 4, 2 plus 2 4, 2 plus 2 4. So that is equal to 512 distinct hypothesis. So each hypothesis containing one or more pi symbols. Pi symbol represents won't take any value. Represent this empty set of instances. That is it classifies every instance as negative. That is the meaning. So that we are going to represent it with 1 plus, so 4. This is 3 is there along with that one negative value. So 4 plus 4 into 3 into 3 into 3 into 3 into 3. That is equal to 973 semantically distinct hypothesis. Okay. So that is there. Then next is consider the two hypotheses. So first one and second one. First hypothesis we are representing sunny, that is the sky here is sunny. Sky will be sunny and other attributes can take any values. And then other 2 attributes. Next is wind is strong. Another attribute can take any values. Then H2 equal to sunny. Even this will be made as positive, the question mark. So now we'll take this. So the instances that are classified positive by H1 and H2. H2 imposes fewer constraints on the instances and it classifies more instances as positive. That means H2 is more general than H1. Okay, that is the main thing. So given hypothesis Hj and Hk, Hj is more general than or equal to Hk if and only if any instance that satisfies Hk also satisfies Hi. Okay, that's the reason we are telling Hk is more general than, Hj is more general than Hk. Okay, that's the reason. So now Hi and Hk be the Boolean valued functions defined over X. Then how we are going to represent Hj is more general than or equal to Hk means Hj is greater than or equal to Hk. That is the meaning. Hj is more general. This Hk will be a subset of Hj. Okay, that's the reason we are representing like this. If and only if for all x belongs to x, Hk of x is equal to 1. Hk is specific. So that is a subset of h of x. So h of j of x is equal to 1. Okay. So from this is moves towards a specific to general. Okay, so this is a diagrammatic representation. Here we will take instances. The two instances are represented x1 and x2. These are there. This here hypothesis is represented h1, sunny and this strong. Then next is this sunny and other attributes can take any value. Then h3 is sunny. Other three attributes can take any value. Next is cool. So here we will take from h1 is specific. Specific to it moves towards a general. Okay, from top to bottom we'll take, it moves from specific to general. If we'll take from bottom to top means it will be general to specific. Okay, so the subject that what we can tell is H2 is more general than H1. H2 is more general than H1. That only you should know that. H2 is more general because here this wind already we have given strong. Next that is also general. It can take any value. So that is H2 is more general than H1. So this like this concept learning is such that can happen. Okay, so I think people have understood the concept learning. Next class we will see the example algorithm.